Welcome aboard my virtual space station and to the latest of our videos looking at how science is helping to tackle the planet's climate crisis. For the last century or so, humans have been messing up the Earth's precious atmosphere, that thin blue line surrounding the planet, allowing too much carbon dioxide, CO2 and other greenhouse gases into the air, leading to our planet getting hotter. In that time, the world's overall temperature has risen by around 1 degree Celsius. It may not sound much, but it's an average, and is enough to have a serious effect on the planet's weather patterns, with more storms and droughts, along with record high and low temperatures. It's critical that researchers get as much accurate information as possible about what's happening to the world. And key to gathering data are those out there, environmental satellites orbiting the Earth. For more on this, let's link up with Jariah down in Britain.
Hi Scarlett, I'm in the Space Gallery in London Science Museum. You know, it's easy to forget how much the conquest of space has transformed our lives here on Earth. This is a model of the first ever artificial satellite called Sputnik 1, launched by the Soviet Union in 1957.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket.
It didn't actually do much, except send a radio signal containing a series of beeps back to Earth. But the then Soviet Union, which included Russia, was a global superpower and enemy of the United States. So Sputnik triggered what became known as the space race between the two mighty nations.
The Russians chalk up another victory in the space race.
3, 2, ignition.
Engine start.
Lift off.
Ignition sequence starts.
Apollo 11, this is Houston, radio check, over.
Most people accept that the USA won the race when this amazing spacecraft, the Eagle, landed on the moon in 1969.
It's one small step for man, one giant leap for mankind.
The space race led to great advances in space technology. Satellites now provide us with everything from weather data to TV pictures to GPS route finding info for phones and cars. Since 1972, the American Landsat program has launched 9 satellites to monitor the Earth. It's the longest ever scheme to gather detailed images and data to see how the planet is changing. For example, enormous areas of Brazil's Amazon rainforest can be seen disappearing in this animation of Landsat satellite images from 1975 to 2012. It highlights a big issue for global heating as forests help absorb CO2.
Up here, orbiting the Earth, there are 2 real space stations with crews aboard, and there are thought to be over 9,500 active satellites. Satellites are blasted into orbit on board rockets and then released at different heights above the Earth. The majority, over 80%, are in what's known as low Earth orbit, a similar height to the space stations just a few hundred miles up. But a few, around 10%, go much higher into what's called a geostationary orbit. At just over 22,000 miles up above the equator, they take exactly 1 day to orbit the Earth. And as the planet also takes exactly a day to make one turn, the satellite always stays above the same point, appearing to be stationary. It's incredibly useful, meaning for instance that a TV satellite dish can always point in the same direction to get a signal, or a weather satellite can always keep an eye on the same area.
You can check out a lot of satellite images online.
This animation I found shows how global heating has affected the frozen ocean at the top of the planet. The area of Arctic sea ice has shrunk by over half in the past 40 years, affecting both local people and animals.
This is a very cool way all of us can help research what's happening to one Arctic animal using this WWF app, Walrus from Space.
The wonderful walrus depends on sea ice to rest before heading back into the ocean to catch prey. In such a vast area, it's hard for researchers to work out how many walruses are left.
So scientists working in the Arctic have joined with WWF on the first ever full population survey of walruses.
They're using satellite images from hundreds of miles up, taken with very powerful cameras which give pictures detailed enough to show walrus groups.
But there are thousands of images coming in, so they want us to become walrus detectives, looking through the images to locate colonies and then counting how many animals there are.
That is so cool. And I found a similar animal research project in the Antarctic, except that it relies on satellites spotting poo. WWF and the British Antarctic Survey wanted to check how penguins are being affected by global heating. The cute Antarctic animals can be really difficult to spot in their white, icy environment. But scientists realised that from space, each colony produced a brown stain that the satellites could see. And yes, you guessed it, the brown is the penguin's poo, known as guano. The images have found previously unknown colonies and can also track how a colony gets smaller or moves location. For more on the latest satellite technology, let's go back down to Jiraiya in the UK.
I've come to RAL Space in Oxfordshire, which is the UK's National Space Lab.
It's here that they help build and test a groundbreaking new environmental satellite called Microcarb. Its vital role is to measure how much carbon dioxide is being emitted or absorbed at different locations. On board is an incredibly powerful camera that can take special video of a particular place like a factory or a forest. The video is fed to a device called a spectrometer that can analyze the light coming in to measure the amount of CO2 either being pumped out or absorbed. The satellite covers the entire planet in just a few days and will be able to measure, for instance, how the amount of carbon dioxide emitted across a city changes over the seasons. Knowing all this will be invaluable in helping take the right decisions to tackle climate change. But it's a ginormous amount of data coming in.
That's why you need a big supercomputer like this one here at the SPSC National Data Centre to help analyse it all. Jasmine is the UK's leading environmental supercomputer, bringing in data from over 100 observation satellites. I mean, it's so loud in here that I have to wear these ear protectors and press the button to talk.
This is what it really sounds like.
Storage is mind-boggling, about 70 petabytes. That's 70 million gigabytes. I mean, Jasmine has a storage of over 500,000 phones similar to mine, which means the owners can fill 6 Wembley stadiums.
A great way to display the results is to feed them into an interactive globe like this one here at RAL Space.
Then you can quickly see what the satellite information means for the Earth.
For example, this is a satellite image of methane concentration over the years. Methane is another critical greenhouse gas, and the display shows how it's reaching dangerous levels. All invaluable information to help us tackle our climate crisis.
One thing that astronauts often say is how fragile planet Earth looks from up here. A small blue sphere containing everything we know and rely on, hurtling through the vastness of space. Well, I'm lucky enough to be joined from the Science Museum by British astronaut Tim Peake, who spent over 6 months on the actual International Space Station. Hi, Tim.
Hi, Scarlett. Well, I'm really envious of you being up in the space station.
Maybe not quite as cool as the real one. So what were your thoughts when you first looked down on planet Earth for real?
Well, Scarlett, looking down on planet Earth for the first time is absolutely incredible. The biggest thing you notice is that you're outside of Earth's atmosphere and Earth is just against this black backdrop of space that goes on forever. And Earth just looks beautiful against the color black. You know, all the colors of the atmosphere, the oceans, the oranges of the deserts. It's clearly a planet that is teeming with life. And then at nighttime, all the lights of towns and cities come out. You see thunderstorms, you see the aurora. It's truly beautiful as well. So it makes you realize we live on the most magical planet.
So how important are satellites to life on Earth?
Satellites are really important because not only are they helping us go about our day-to-day lives, but also in terms of keeping an eye on what's happening with our climate. So they can be measuring forests, how much greenery, biomass we have in the forests. They can be measuring how much salt is in the oceans. That helps us to track how much ice is melting at the caps. They help us to track leaking gas from the planet, whether it's methane plumes or how much carbon dioxide is building up in certain areas. So very important to us.
So in the future, do you think we'll have the option to live on a different planet?
I think people will live on another planet. That may be hundreds of years away. Between now and then, I think we'll gradually make small steps towards that. And the first thing we want to do is go back to the moon and set up a research laboratory there, which is really exciting. But all of these things will help us one day to perhaps be able to spend lives on another planet.
Well, thank you so much for joining me.
Thank you very much, Scarlett. Great talking to you.
It's all very, very exciting. But as Tim said, there's no place quite like our home down there. Hopefully, satellites, coupled with human ingenuity, will play their part in making sure our descendants have a beautiful planet to live on for generations to come.